So I think I can just start. So the purpose of this meeting here, this gathering, is to talk about some advanced features for NIC and Beryllium timeframe, and talk a little bit about planning. So ideally, if we can discuss about some topics and try to figure out how we're gonna at least direct the solutions that we're gonna do during the course of Beryllium. Of course, we're gonna have lots of meetings on Fridays to talk about how we're going to design and everything. At least to have some directions and prioritizations. It's going to be okay. So I have my colleague from HP Labs, J.K. Lee, here to talk more a little bit about one idea that we're going to talk about here. So 5 features I would like to discuss. We can discuss more if we have time. But one is a extension to the model for conflict resolution today. It's a graph model for intent abstraction and composition that JK is going to talk about. Label namespace for eager and proactive policy composition. Intent ACL actions separated from non-ACL actions. We're going to talk about that as well. Then other items like control loop and mapping service. And a little bit more about base actions that we need to support during the course of Beryllium, plus dynamic actions, dynamic constraints, like an extension model for those. So with that, I would like to call JK here so he can start talking about the graph. You can just use this.
Yeah, perfect. Okay. Hi, I'm J.K. Lee from HP Labs. Thanks for giving me this chance, and you guys really did a great job for the lithium release of the NIC intent composition engine. So on top of that, I'd like to kind of introduce some interesting advanced features we can build on top of what we have right now for the Beryllium release. So the first item is, as Raphael suggested, I will talk about the graph model that we can easily map on top of existing APIs. So here we have some 2 examples or policy or intents from 2 different users, like application administrator and cloud operator. And application administrator is allowing exclusive HTTP access from the marketing employees to app for to the load balancer. So it's a combination of ACL policy or intent and also service chain intent. So in NIC world, we can say that allow is a combination of allow and redirect actions. And the cloud operator also has a similar intent for the entire traffic from campus to cloud is allowed if they are using some 3 port numbers or protocol fields, and that traffic should go through firewall. So it's also ACL intent and also service chain intent. And if we have a kind of marketing employees placed in the campus and then web servers are hosted in the cloud, and basically we have overlap of the traffic, and then they have some partial conflict between them because non-marketing employees sitting on the campus cannot talk to the web servers because it's blocked by the application administrator intent, but is allowed by the cloud operator. So this is one example of having conflict between 2 intents. And then we could have actually expressed that using the NIC APIs, then using such a human language type of APIs. But another way to represent these 2 intents are just using graphs. So this is typically how we had to discuss and reason about such intents in using whiteboard, for example. So you have an application administrator graph, the marketing node talk to web, and so there's an edge, meaning that the traffic is allowed, and then port 80, basically HTTP traffic is allowed, and it's exclusive to the marketing. And same as a cloud operator can draw a graph between campus and cloud, and then place a firewall box in between. So this is the ACL plus the middle box intent. So if we compose them into the graph domain, we can cleanly capture both intents at the same time, assuming that the exclusive ACL has some priority. So then in the composed graph, we can see that the traffic from marketing to web is going through 2 boxes, firewall and load balancer, because firewall is required by the cloud operator and the load balancer is required by the application administrator. And then there's no edge from the non-marketing in campus to web, because that's blocked, not allowed by the application administrator intent. So this is kind of showing the benefit of using graph abstraction to express your intent and also doing composition in the graph domain. And for that, we, based on such benefits of using graphs, we formally define a graph model to describe such intents in using various APIs. So here, I'm showing kind of 4 different intents from different stakeholders, starting from enterprise IT and application admin, and then SDNM and cloud operator. Some of them might be familiar to you guys. So if you take a look at graph B, which is application admin, basically there are 4 intents are expressed in just one graph. So there is an edge from the employee to web, and web to database, and database to database, because there is a kind of traffic should be allowed between database servers for synchronization, etc. And then there is a load balancer box sitting between employee and web. So that's just basically service chaining intent. So there are 4 intents are captured in just one linear graph. It's pretty easy to look at and then reason about that. And the graph C is a kind of HP word, net protector word. You probably heard about that from other examples, that what it intends is that the DNS traffic from the normal clients are examined by DPI, and if DPI service, virtual service detects something wrong, then we quarantine that client into the quarantined state. So we have another EPG for like a quarantined, and it can only talk to remedy server. So we had an example of some exclusive access, and that kind of intent can be easily captured in graph by using just different color on the node. So the blue node means exclusive. No other access edges can be added to this node. So that's another intent API. And then graph D is a cloud operator's intent. Here we are using dotted edges instead of solid edges, which means that here is that the operator, cloud operator, is it wants to place the firewall and byte counter service chain for the traffic from campus to cloud if someone else is allowing that traffic. So here the intent is just pure service chain intent, or like a redirect action, which has nothing to do with ACL. So we call this dotted edge as a conditional edge, that it is instantiated if and only if someone else is allowing the traffic, then the service chain is instantiated for that traffic. Any questions so far? Does it make sense to you guys? Okay, thanks. So then, as NIC is doing also GBP and many other high-level policies, we are defining policies or intents using logical labels instead of using network specifics like IP address subnets. If we, you probably heard that all the great talks about what intent is, that one of the goal is not to use such underlying network specific variables or values like a subnet in describing your intent. If we have done that, then that intent is not portable anymore. So we are using such logical labels to define a policy or intent, but if there's no clear relationship is captured between the labels, then it's really hard to use them from the beginning. And also the second problem is that we don't know which policies will overlap in advance. So we have to wait until there will be any virtual machine or client showing up using some IP address and happen to have 2 labels at the same time. And that's when we detect that, oh, actually 2 policies should be enforced at the same time on the same endpoint. Then that's when we actually detect conflicts and resolve it. So there is no way to proactively or eagerly detect such a conflict and resolve it. So what we are trying to do here is that proactively capturing the relationship between labels using this kind of label namespace. Here we have a kind of 3 types of labels, like a tenant label, location label, and kind of dynamic status label. You can think of it as typical key value label. So we have 3 types of keys, tenant, location, status. And for each key type, we are defining the relationship between labels using the hierarchical tree structure. So in this case, the tenant, we have an employee and app, and under app, we have a web and database. So the web and database labels are sibling each other, then it means that 2 labels are mutually exclusive. So no endpoint will have a web label and database label at the same time. So we don't really need to compose the policy written for web and policy written for database in advance. So this is how we can proactively detect which labels will overlap or which policies will overlap and may conflict and try to resolve it in advance before we actually deploy them on the system. And then, so there is a parent-child relationship between app label and the web database label. Then there is an overlap between those 2 labels and policies. Then we should kind of proactively compose them. And we may also have a kind of mapping relationship between labels of different kinds. For example, the database workload can be placed on campus A. Then means that we need to proactively analyze any conflicting relationship between them. And if there's no such relationship, we don't really need to worry about conflict between them from the beginning. So with that information, you may wonder how we collect such information from the beginning. In our lab, we are kind of prototyping this label namespace in OpenStack because there are many kind of data sources in OpenStack, starting from Nova, Neutron, and Keystone. And I think there will be the same thing with the Open Daylight. So my point is that we can just scan through the existing databases and data sources of each individual controllers or services and then extract such a relationship proactively. That's what we are doing. And in case of, I think, OpenStack, Open Daylight, we have a AAA and some other such a key, authentication services where we can get something like a tenant hierarchy key, etc. So with that kind of label namespace information, we can proactively compose the graphs from the left-hand side to something like on the right-hand side. So on the right-hand side, then we have 2 blue nodes, engineering, campus A, and quarantined. So these 3 labels are known to overlap each other because that's given by this label namespace. So engineering department can be placed on campus A, and then the engineering department is using the net protector application. That's why the quarantine label is also kind of composed together in this blue node. But those 2 blue nodes have outgoing edge only to the remedy server because they are exclusive. But the other engineering department, campus A, but with normal status, the white node on the top, it has many outgoing edges to DNS and marketing department and web and cloud because these are all allowed communication from the input graphs. So this is kind of how we proactively and automatically compose graphs. Yes, please. So currently we are working, this is somehow, again, done in advance, even before creation of NIC in the labs. We are part of the research organization. So we have a published paper for this CCOM, and there are many details about that. And we implemented a prototype in Python, and that at that time there was no NIC creation at all. And now we realize that there is a great project happening in this community, Open Daylight, and we internally work together with Raphael to do some kind of POC of that. So we are implementing some of the APIs and then graph-based composition engine into the HP internal fork. I think Raphael can talk more about that. Do you want to comment on this right now or maybe later?
So, want me to? So we have a Garrett review for that.
So we're gonna talk with the community to review like small pieces of code, so we can talk about the idea slowly, get to the final version of it. So in order to merge back to the master branch, but it's today's conflict resolution logic basically is it's just it's a different way of seeing this. So it's just an extension of the model, but. So as JK was saying, it's a research project that they had on HP Labs. Then we saw that we can make it user fit in NIC. And as we are still in the proposal phase of it, it's an experimental project, so we can test new ideas and see if they're worth or not. So that's why I bring JK here to discuss about it, and so you guys can evaluate. But it's not something like it's not a fork. It's something that we are just working on to see how can we leverage the NIC code to go like to next level in terms of conflict resolution. And also we can take some advantages of graph, because graph theory is already there for a long time. It's proven like correct in multiple aspects, and we can take advantage like for optimization. If you want to distribute the graph into multiple cluster nodes, to do the compilation process separately, then recompose. So that's one of the ideas using graphs.
One question. Is this, so here the intent seems to be implicit, right? Is there an explicit intent expressed in that?
So the question is about whether the intents are explicit or implicit. Can you elaborate the question? So what is the difference between that? And is it kind of known terminology in NIC community, or just?
Sorry, I'm relatively new to NIC, so I cannot say that. But I'm wondering was like, because NIC is in the realm of policy kind of methodology, where intent has to be expressed, right, by somebody, you know, whether that's implicit or explicit. In this kind of model, what I'm trying to understand was that it looks like he's more discovering what probably was there. Is that the right way to say it?
Oh, so no. Sorry if there was a confusion about that. So when when the users are composing such creating the input graphs on the left-hand side, these are intents. You can think about just, any type of intent or policy as a kind of, in a simplified form, we have a match and action, basically. So the classifier and then the desired state. And you can think that kind of the label-based endpoint group nodes and also the edge classifiers like ping, HTTP, combination of these two are forming that kind of classifier field. So that's how we identify a set of packets that match such a conditions. And then the type of edge, for example, the solid edge or dotted edge, and then what kind of middle boxes, service functions boxes are sitting on the edge. These are basically forming the action part. So we can easily convert them to existing NIC APIs using redirect or inspect or allow deny kind of actions. And then the label namespaces, so currently we are capturing what the allow the system state or how the deployments or placement happening, and to aid such a proactive composition. So, but these are two different things. Right, so we evaluated the automatic composition algorithm with some large number of ACL policies and written in kind of distributed way. We converted that ACL policies to 136 graphs and then composed them in 10 minutes, creating a large one big graph with millions of edges. So yeah, that's it. Okay, so the final thing I want to briefly talk about is that the ACL API that we kind of came up with as a part of this graph representation. So this is what current NIC conflict resolution happens. I don't want to go into the detail, but if there is an overlap between two policies, then we go through this kind of decision tree to decide which policy wins over the other one. So here, the action precedence is the third kind of decision stage, where we always take the block or deny policy wins over the allow action or allow policy. it works in many cases, but we may have some corner cases like, if there is a IT administrative policy allowing some monitoring traffic from the employee laptops to some servers, but if there is an employee policy blocking that traffic, then we may end up having the traffic blocked by the employee because the block always wins over the allow. Maybe this is a unnecessary corner case, but I'm just saying that just having this deny versus allow may be too coarse-grained. So with that, we kind of thought about having some more finer-grained ACL actions. So instead of having just allow and deny, we have something like a strong allow, weak allow, and block and conditional. So the goal here is to clarify users' hidden intent, and then with this kind of clarified fine-grained intent, the chance that the system can automatically resolve conflicts is increasing, or in the other way around, the chance that we have unresolvable conflict is decreasing. Let me show you how these can be useful. So in the typical whitelisting model, let's say we have a source and destination, and then we have a clear intent to allow HTTP and HTTPS. Then we can select for the default edge in the kind of graph composure that default edge is must edge, which is strong allow. So if you draw any edge from the source and destination with some classifier, HTTP, HTTPS, then they are allowed no matter what. But the meaning of the no edge, so it can be set as a block or conditional. Block means if there's no edge from the source and destination, then it should be blocked no matter what. Or conditional means that I don't really care. Someone else can allow it. And for the blacklisting case, let's say you have a clear intent to block SSH and ICMP from the source and destination. Then you can draw such a block edge from the source and destination, meaning that it should be blocked. But for the other protocol fields other than these two, what do you want? Either you may allow them somehow, but using kind of must allow may be too strong. So like a HTTP, HTTPS, which are not listed by the blacklist, you may allow using some weak allow kind of intent. So it's definitely different from the allow that you would use for the whitelisting. So that's where we can use some kind of weak allow, which is can communicate as a default action for the meaning of the no edge. Okay, so with that, this is how the composition would happen, because now we have a 4 type of edges: must, can, block, and conditional. Then previously we have just the 2 actions like allow and deny, and then the chance for conflict is just 50%, right? But with this 4 type of ACL intents, then chance reduced down to 12.5% just mathematically. Just 2 out of 8 table boxes will be the conflicting case. So that's the kind of benefit of using this for finer grain ACL intents. And then if we can proactively detect such a conflicting case, then to resolve that conflict, we can actually ask users, hey, we detect such a conflict between block and must, then what do you want to pick? So that's the also benefit of doing this proactive composition. Yeah, I think that's it. So status, yeah, we kind of doing some POC internally to see how it works well with the internal and ACL intents, the 4 type of ACL intents, and then graph composition. And then in HP Labs, we have some GUI developed for it. If you are interested, I can show you later on. But in general, it's not just research work or paperwork. Any feedback from this kind of community will be really appreciated. Thank you.
So yeah, the rest of the discussion was thinking about having like a very open conversation with you guys about some of the things that we are doing. One is allowing people to build their own custom dynamic actions, like building a piece of code and archetype Maven archetype that you can basically extend the behavior of NIC, adding new, augment the model, the young model that we have today to add new actions, new constraints, and express what happens when that got it executed. So if you create like a custom action that logs some message in some syslog server, for instance, you can just like write a piece of code that connects to a socket and then sends that text to the syslog server and augment the model to add that particular, let's say, syslog action. And that keyword got, once you load the bundle into the OSGI container, augments the model, and basically NIC now can read that information, parse it, detect which particular plugin has knows how to handle that action, and basically do it. So, and another thing that we have to discuss. Okay.
I just have a question. So if you have a dynamic action, does it mean I have to review the controller to be able to do that? Or is it imperative? Like, can I define it in a configuration file that fits intent and then it knows how to execute it? Or, like I think it's kind of too much to kind of write a piece of code that makes it into the controller before you could actually integrate the dynamic action that you're talking about.
Yeah, so there are two models for that. One thing you guys are doing Boulder, right? So you can run those scriptlets in the controller, like inside some sandbox that has some particular functions that you can execute. Maybe it's too much, right? Like you said, right? Make this too open. We're gonna have a set of actions that is like will be there by default, like if you have inspect or monitor, redirect.
You can have primitives, right?
Yeah, exactly. Primitives are there.
And then you can build things from primitives, so that way you don't have to review the controller to do that.
No, yes, exactly. Yeah, exactly. So the default actions will be there. So this is just an extension model. So so this point actually is so I think that one actually Renato is working with the dynamic actions. So you want to give some input on that? No, it's okay. So you can discuss. He's a shy guy. He wants to discuss in the community. So, but basically, we're gonna discuss about that. So there's no big there's a model there. We can just discuss in the community if the model is valid. We're gonna start working on that, and then building the final solution. So another thing that we have to talk about is how. Let me get back to the okay. Yeah, so how we are gonna work out with the mapping service. So the mapping service is where the magic happens. So JK was talking about the label trees, right? So you can do either proactively detecting the particular names from, like you said, like from another domain that has the common names in the network that you already have, or you can also create on demand those things. But and GPB group-based policy already has endpoint service, right, for naming resolution. So ideally, what do you guys think about? You guys think we need to like start contributing with group-based policy and particularly for endpoint groups, or build an internal service that basically does, because then we're gonna put a GPB under the same like in the stack of NIC, right? So as a dependency that might be problematic.
Question is, does endpoint groups provide everything that we need? If it doesn't give us all the stuff that we need, then we should build something new.
Yeah, and then as another discussion is, it's too complex today to leverage, and the things that we need are really much more simple.
Well, I wouldn't say so. So, for example, endpoint groups can let you define L2, L3, L4 attributes and use it to define what the group actually represents. So it could be a network, a subnet, network, subnet, selection of ports, and all that. The basic thing is that you're defining what you can attribute as a name that becomes a subject in intent. So the person creating the intent actually doesn't have to know all the details, just knows that it's been defined for them. Now the question is, if we have that, and that is populated before someone actually goes ahead to define an intent, then the intent becomes composable, and it's very simple for you to actually just say this is what you want. But I don't see how we can define things like traffic. So I was asking you the question about the constraints. Like if you look at the slides over there, we talked about like HTTP, HTTPS. We don't have a way of defining those, so that it's all the same kind of pattern like endpoint groups. So maybe we need something different, or maybe we can use that, but I don't see how we can do that with the group-based policy endpoint groups.
Okay. So today, I don't know if you guys all recall the model, right, that we have. So the model that we have is a subject, action, condition kind of model, right? Right here. So the base model today it's not in the right screen. Sorry. So the base model today is there's a source, action, and condition and constraints. So your point is when you talk about traffic, right? HTTPS today it's a classifier, right? So the decision that we took was let's embed the classifiers into the subject, right? So if you talk about when you create like allow web traffic from Bob to Mary, so you're basically saying this web traffic, that means like port 8N443, for instance, or an FTP connection, I don't know. And then that will belong to one of the subjects, and we're going to extract, there's going to be like a parser that extracts from the subject that information, because that information is actually from the flow, right? So it's not something that belongs to either subjects. It's a property of everything. Yeah. Yeah, but then I think there's a semantical discussion there as well. So can we define that as some kind of traffic constraint, like a traffic profile? Yeah, because that's the same discussion that we had when we start discussing the model about. I don't recall exactly, but there was the same thing at when you have conditions that are time-related stuff, right? You have like a scheduling with specific time. So it can be like seen as a time constraint as well. So everything could be like constraints. So maybe we need to touch base there and see if that's the right model or not, or if we need to modify anything. And I think that even related to JK, maybe we need to change a little bit. If we decided to go in the graph direction, maybe we need to do some changes in this model as well to make it easier to port to the graph model internally. We did some experiments like internally transforming to a graph based on the current model that we have for intents. It works, so you can generalize, but it could be much easier if we modify a little bit. But as we said during the NIC's meetings and everything, so this model is pretty much like an experiment right now, so it works pretty much the way that we think. But
it actually works, but we don't have mechanisms for defining what a subject actually means right now. So if you look at all the renderers that we have, group-based policy can pick the endpoint group because group-based policy defines that. But I think for VTN, we still have IP addresses, right? So we need to be able to have some common way of defining what a subject is or what a classifier is that all the renderers can use so that they kind of see the same thing and behave the same way.
Yeah, and that leads to the conversation about the multiple renders. So today we support multiple renders, but multiple renders are just listening for changes in the config tree of the intents, right? And they act. So depending on the stack that you have of renders, then you do something else. So if you have group-based policy render, you do something. If you have VTN, you do something else. If you have your own render, you do something else.
But if they can use the same registry for both, they can define it differently, but you have the same registry, then all of them can actually leverage that.
But then there is a question. Okay, so if you have support for multiple renders, then we need to, we want to take advantage of the conflict resolution. Then the notification part happens after the conflict resolution. So if that happens after the conflict resolution, then might be composition there. So if VTN render is performing some action, group-based policies perform some other action, and I need to compose, and I have multiple renders, who is going to render that? The composed version. So then you have this problem of having multiple renders that I was always talking about.
It would be nice to have one renderer. I don't know if we can do it right now, but that would be the best if we can get that to work.
Yeah, but if you have composition in place, right? If you start composing, because some things that you do on VTN and some things that you do on group-based policy can be composed. You don't need to keep like different actions being pushed. You can like push the same action. If they conflict, for instance, you can compose. Mm-hmm. Because today, okay, so today you guys are doing, you guys render block and allow actions equally, right? So today if you have, you cannot have VTN and group-based policy running the same, okay? So we have to select one render. So you don't have multiple renders, you have one render. So you always have to choose a render when you start building your stack, intent stack. And I don't know if that's the way to go. So it's might be complicated. So Gabriel, you want?
Yeah, it's just I just have a question. From what I've seen, you want to use graph to resolve conflicts, and I'm just wondering how you're gonna store that within MDSL. I'm just wondering how you see that. I don't, because you can't store graph.
Yeah, exactly. So yeah, so that's another point. So today we're storing the graph in a different structure. Yeah, if you want to take advantage of the distribution of MDSOL and everything, then we have to think about it, how we're going to store MDSOL or not. I don't know.
Well, I'm sure.
But it's a completely ephemeral information. So you cannot guarantee that the composed graph will be, let's say, in the scenario that you shut down a node, once you get back, I don't think that we need to preserve the state. We can just recompute the graph if it's fast enough. So I don't know if we need to really store the composed graph, because if we have the intents in the MDSOL anyways, so the composed graph is a representation of the multiple intents in the form of a runtime memory object that gets shared across the state. So I don't think we really need to store the graph in the MDSOL right now. I don't know. The good thing is also that you can have multiple clicks of the graph spread around. Also, we can separate. The conflict will be, so the question was, how do we communicate the conflict to the renderer, right? So, no, but the conflict is not something that belongs to the renderer, I think. It's something that it's taken care in another level. So we really need to do two things. If we have a conflict that is unsolvable, we need to tell whoever pushed the intent, whoever asked to apply that intent, we have to tell them that the state machine say, hey, your intent is not fulfilled. But then we have two kinds of treatments. We can say, hey, we cannot do it, or here are some alternatives, or the most approximate thing that we can do right now. The renderer is just rendering, so I don't think that the renderer has to do conflict resolution as well, or we.
No, but the renderer must ultimately wait for whether I can really render this intent or not, because if there is a conflict, I might have to undo something that I have rendered, or maybe.
So, but the renderer is not intent aware, right? Yeah. I don't think even that the renderer should be intent aware. So intent is something else. So intent sometimes is something that is end-to-end, and the renderer actually doesn't know about it. So like QoS intents, like it's something that happens along the path, and then that's why we're talking about yesterday about there are multiple levels of conflict resolution. Sometimes it happens in one switch, then you solve it, like the conversation that we had here. Sometimes it happens along the path. Like if you have a conflict resolution in terms of resources or QoS resources. So it happens like not in one switch, it happens in multiple switches. Yeah, you should talk about it.
Yeah, my high-level understanding was the same. Basically, in order to enforce or deploy multiple intents on the given network, there are kind of two types of conflicts. One is the intent-to-intent conflict, and the other one is intent to kind of underlying resource constraints or topological constraints or limitation kind of conflict between them. So I think NIC, what we are doing in this intent composition is just resolving the conflict between intents orthogonal to underlying resources. Once we resolved those conflicts and came up with one just system-wide intent, then that's where I think is the best time or place to worry about the conflict with the underlay or resource conflicts.
Yeah.
No, then it becomes like when a new intent user commits a new intent, you will be scanning through the rest of the already committed intents and trying to resolve conflict and putting something in the data store in place. Then the renderer will take over, or then the renderer will act on it, or how is it like?
If you think about it, right, we just gonna detect when the change happens. You have to go evaluate which parts of the graph actually are impacted by that change. So using graphs is actually much better than use the current algorithm implementation that we have, because you can look for because they're related, right? So you know exactly the neighborhood that you need to take a look. After that, then we need to transform that into the actions that we really need to do in the network. Then we're gonna call the render. Say each render, what do you need to do?
Okay.
Yeah, exactly. Yeah. So based on that, we're gonna send this first version of the implementation to the community. Small patch, abstract, so we can discuss on top of that. See the failures, something that we need to change. Then we can commit to something and see if it's feasible for Beryllium. I think it is. I don't know if it's gonna be like the whole.
Maybe it shouldn't be the whole thing, because one of the things that we want to do with intent is to make sure that it's simple for the end user. And I know that group-based policy is great. It does a lot of things, but it's very, very complex for a lot of people to be able to use. So if we can keep, all the graph stuff is great, but if it's abstracted for the user so they don't actually know that.
No.
And then if we're doing conflict resolution, it should happen before rendering. So at the same time, we can use all the renderers that we have and be able to reuse the code in the project. But then we can do the conflict resolution before we render.
Yeah.
And
So one thing that I don't think is clear enough. So JK actually said about that, they have a graph interface and everything. But in our case, it's intents. Internally, we do that because there is a direct correlation. It's a isomorphism kind of thing, homomorphism kind of thing. So you can transform the graphs into the expression that we have in intents. So we just take that place, actually. So internally, there's a graph representation that we use to take advantage of all the good things about the graph theory that we have, and that conflict resolution before even something happens. But it's not like the user does not know, doesn't care if there's a graph, it's not a graph. Doesn't matter. It's internal representation.
what about the classification process? You have subjects and you have this graph that kind of puts them in a hierarchy. Is that something that we also have to expose to the user to be able to define?
Oh, you mean that label tree, right?
Yeah, the level tree. Yeah. So because I think that is fairly complex at this stage for.
Yeah, the label tree, you can think about a lexical tree. I don't know, something that has the relation between those known terms. So it's something that I think it's a plus. Yeah, it's optional.
Okay. Maybe we shouldn't.
It works even without that.
No, we're 5 minutes over, and that means that people can't get to the key signing. So.
Oh, okay, got it.
So if we could shut it down, and again.
Yeah, I'm gonna
great
open a
dis-
new session
but
for
at the
the other points.
Excellent. Yeah, great session.
Yeah.
Yeah, let's do a follow-on. Put it up on the unconference, and we can continue it.
Okay,
tomorrow.
so thanks everyone for joining. We're gonna have a continuous discussion tomorrow, particularly in the other points. And thanks JK for showing up, man. Thanks very much.
Conflict between two intents. And then, we could have actually expressed that using the NIC APIs, then using such a human language type of APIs. But another way to represent these two intents are just using graphs. So this is typically how we had discussed and reason about such intents in using whiteboard, for example. So you have an application administrator graph, the marketing node talk to web, and so there's an edge, meaning that the traffic is allowed, and then port 80, basically HTTP traffic is allowed, and it's exclusive to the marketing. And same as a cloud operator can draw a graph between campus and cloud, and then place a firewall box in between. So this is the ACL plus the middle box intent. So if we compose them into the graph domain, ACL policy or intent, and also service chain intent. So in NIC world, we can say that allow is a combination of allow and redirect actions. And the cloud operator also has a similar intent for the entire traffic from campus to cloud is allowed if they are using some 3 port numbers or protocol fields, and that traffic should go through firewall. So it's also ACL intent and also service chain intent. And if we have a kind of marketing employees placed in the campus, and then web servers are hosted in the cloud, and basically we have overlap of the traffic, and then they have some partial conflict between them because non-marketing employees sitting on the campus cannot talk to the web servers because it's blocked by the application administrator intent, but it's allowed by the cloud operator. So this is one example of having.
So I think I can just start. So the purpose of this meeting here, this gathering, is to talk about some advanced features for NIC and Beryllium timeframe, and talk a little bit about planning. So ideally, if we can discuss about some topics and try to figure out how we're gonna at least direct the solutions that we're gonna do during the course of Beryllium. Of course, we're gonna have lots of meetings on Fridays to talk about how we're gonna design and everything. At least to have some directions and prioritizations. It's gonna be okay. So I have my colleague from HP Labs, JK Lee, here to talk more a little bit about one idea that we're going to talk about here. So 5 features I would like to discuss. We can discuss more if we have time. But one is a extension to the model for conflict resolution today.
From HP Labs, thanks for giving me this chance, and you guys really did a great job for the lithium release of the NIC intent composition engine. So on top of that, I'd like to kind of introduce some interesting advanced features we can build on top of what we have right now for the Beryllium release. So the first item is, as Raphael suggested, I will talk about the graph model that we can easily map on top of existing APIs. So here we have some 2 examples or policy or intents from 2 different users, like application administrator and cloud operator. And application administrator is allowing exclusive HTTP access from the marketing employees to web for the load balancer. So it's a combination of.
It's a graph model for intent abstraction and composition that JK is going to talk about. Label namespace for eager and proactive policy composition. Intent ACL actions separated from non-ACL actions. We're going to talk about that as well. Then other items like control loop and mapping service. And a little bit more about base actions that we need to support during the course of Beryllium, plus dynamic actions, dynamic constraints, like an extension model for those. So with that, I would like to call JK here so he can start talking about the graph. You can just use this.
Yeah, perfect. Okay. Hi, I'm J.K. Lee.